0.65, right? So as usual, we have to ask the question whether this concordance index value 0.5 for A and B is greater than strong concordance or not. It is no. The answer is no. Is it greater than weak concordance value? Answer is yes. We have taken weak concordance value as 0.5. I have already discussed about this. And in case of discordance index, the value is 1. Threshold value of strong discordance is taken as 0.7. Is it less than that? No. So what is the decision? Strong, weak, or no outranking? We will say no outranking. Because although it is weakly outranks B, because for strong outranking it is no, but for weak outranking it is yes. So it is weakly outranking with respect to concordance, but it is not outranking with respect to discordance. So this ELECTRE II method is like that only. Even if in case of concordance A outranks B, but discordance can veto that decision, penalty that decision, if the discordance index value doesn't is not less than the threshold value of D. Threshold value of D means strong D. Okay. So no. For the next case, C concordance index between B and A value is 0.5. Threshold value for strong is 0.65. Then no. Threshold value for weak is 0.5. So it is equal. So it is yes. For discordance, the value is 0.5 and this threshold value is 0.7. So is it less than that? Yes. So B weakly outranks A. And none of the condition has been met for the other combinations. So all the answers have become no, 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 no. So this is the strong and weak outranking. Next and last step is distillation. One is ascending, one other is descending. Descending means top to down approach or best to worst approach, and ascending means worst to best approach or down to up approach. So let us go to the example straight away, so that way you will understand more. You see, this is result as per descending distillation. So this is the same table, that is this one. This table I have just copy pasted into this table. I think you can understand that. Okay. So now after I have copy pasted, this is the decision actually. Let me use a lighter color. This is the decision actually. Correct. This is the set. This is the concordance of value, threshold value, question, threshold value weak, question, and this is the discordance, value of the discordance index, and so on. Right, so there is no outranking. So the score assigned is to A is 0, score assigned to B is 0, everybody is 0. And score assigned to C doesn't matter because we are comparing only between A to B. So in case of weak outranking between B and A, you see B weakly outranks A as I have discussed earlier. So as I have discussed earlier, B weakly outranks A. So B is given a score of +1 and A is given a -1 because B weakly outranks A, but it has outranks A. So B wins. So that is why +1 is assigned to B and -1 to A. So for all other cases, we are forced to assign zeros because there is no outranking between the conditions, between the alternatives for these comparisons. Like for example, B and C, no outranking, so A is not required, but for B and C we have given 0. No outranking means zero. Score is zero. If there is outranking, the alternative which is outranking the other alternative gets plus one, and the other alternative gets minus one because it was outranked by that alternative. So accordingly, we assign scores, and when all the scores are assigned, you see total score of A becomes minus one, total score of B becomes plus one, total score of C becomes zero. Now, which is the highest score? This is a descending distillation, so best to worst. Which is the highest score? That will be assigned to class 1. Second highest score, class 2. Third highest score, class 3. Best is class 1. Worst is class 3. So accordingly, if I compare, you see B has the best value, class 1. So it was assigned to class 1. C is not best, not worst. It is in between. So it was assigned the class 2 because it has a score of 0. The total score will show you which class to assign. And A has a score of minus 1. Certainly it is negative, and it is the second best value. Sorry, third best value, because within minus 1, plus 1, and 0, plus 1 is the best value. 0 is the second best value, and minus 1 is the last best value. So class 3 is assigned to variable A or alternative A. Now, as per the ascending distillation, as per the ascending distillation, what will happen now? As per the ascending distillation, you see same thing, but the worst will get the worst value. That means score assigned to A is minus 1. This is the worst. That means change the color now to red again. This is the worst value. This is the best value, right? So in case of worst ascending distillation, worst to best is followed. Sorry. In case of descending distillation, best to worst is followed. Yes, I have told you the right thing. In case of ascending distillation, worst to best follows. Bottom up follows. So worst is which one? Can you say which one is worst? In this case, what will happen is the worst class will be assigned the worst value or worst ranked alternative as per the score will assign the class 1. So A is minus 1, which is the worst thing, so it will be assigned class 1. And B is plus 1, which is the best thing, so it will be assigned class 3. And C is in between them, so it will be assigned class 2. Right? So what happened is, this is the worst class. I have written here in not correct. This will be the worst class, and this will be the best class. But in this case, this is the best class. Indeed, this is the best class because it has the highest score. This alternative B, and this alternative A has the lowest score, minus 1. In between them, alternative C. So the best class is assigned class 1, worst class is assigned class 3, and between is class 2. So best class is class 1, right? So best to worst, top to down button, right? But when we are doing the ascending distillation, we will assign the class 1, which indicates the means the class 1, first class, to the worst